Welcome to another edition of AI Impact and Strategy. Today we're going to be talking with Dr. Stephen Dam, who's the founder of Spec Innovations, a firm which has developed a very powerful tool for systems engineering models called Innoslate. If you've watched previous videos on this channel, you may have seen a couple interviews I did with Tom Brazil, who is an AI power user and has developed, among other things, about 90 AI agents that he's using in his company to save hours and hours of time. In a recent conversation, Tom suggested that I should talk to Dr. Dam about Innoslate. So a little clip about that is at the beginning of this video, followed by my discussion with Dr. Dam.
Innoslate was the most innovative model-based systems engineering tool at that time in 2017. And all he's done is integrate more features and capabilities. So he had, of course, Monte Carlo simulation built into it. He's used it for lunar rover engineering with a digital twin capability. And of course, way back in 2017, he already had natural language processing built into it. I mean, it built out model-based reviews and everything based on just natural language understanding. It's just fantastic. He's been enhancing that continuously, and I guarantee you need to have a conversation with him.
So that was Tom Brazil talking about Dr. Stephen Dam. Now, systems engineers design very complex systems like power plants, automobiles, aircraft, and spacecraft. And because these systems are so complex, they use a category of tools called model-based systems engineering, a practice which was pioneered at MIT during the 1990s. I was interested in particular in hearing from Dr. Dam about the application of Innoslate systems engineering for economic and social modeling, which we think is going to be important for policymakers who are now considering the future of AI in their nations. As I mentioned previously, we're starting to work with national governments on AI strategy. And we think that helping government leaders to model various alternative policy options will lead toward the adoption of better policies because leaders will understand the likely consequences of the choices that they're making. So this is all rather technical, but if you are technically minded, also very fascinating. As society becomes more complex and the technologies that we're using become more complex, it's critically important for government leaders and business leaders and citizens to have the opportunity to explore the possibilities for the future before they make irrevocable choices about the futures that they're going to adopt. If you're interested in complexity, systems, and systems modeling, I think you'll find this video very interesting. Let's meet Dr. Dam and learn more about Spec Innovations and Innoslate.
I'm Steve Dam. I'm a PhD in physics. We have a company, a small business that we've been working since 1993. But we mostly do systems engineering work, and we have a tool called Innoslate, which is helping people do better systems engineering. There's so much in systems engineering we're looking at the whole breadth of the system. We're not just looking at one little component of the system and try and get it right. We have to get all of it right and optimized, balanced across all the different things and all the disciplines. These systems are so complex, you can't keep the system in your head. So I see the AI as a tremendous assistant. Have you seen the Iron Man movie and the introduction of Jarvis?
Mm-hmm.
That concept is kind of my vision of where I would like to go. I would like to have that snarky AI.
With that attitude, huh?
A little bit of attitude, which is always good, to keep you on your toes, and be able to have that interaction and be able to create like that, and take that mechanical part of the creation away from the human.
Right.
The AI do all that stuff. We're being the creator.
You should possibly have a conversation with Tom Brazil because I think he's very well down the road of doing that. I interviewed him, and there's a video on the channel now with him. He's got more than 90 agents working at ICS now, and he has an agent that's coordinating the other agents.
Wow.
And one of his agents is called the AI Superintelligence Agent, and it's programmed by Tom to have an attitude. So it's kind of a smart ass intentionally. Uh, and Tom set up a conversation between one of his agent, between that superintelligence agent and an agent that some other programmer had created, that was an omni intelligent agent, I think. And he let the two of them have a conversation, which was really fascinating. So
Yeah, Innoslate was developed back, we started the development work back in 2011, I think, because we were using a variety of tools over the years, but they just weren't modernizing. They were desktop tools. They wouldn't scale. You couldn't easily collaborate with them. And we'd be working on some of these big projects like the Future Combat Systems for the Army. And they had 400 modelers. Well, that doesn't work when you got desktop software and databases, and you got to merge them, and it's just a nightmare. It's a configuration management nightmare. And so we ended up building Innoslate to try to obviate those kind of problems. How do we create that collaborative environment? And the cloud gives you that naturally. And then the other thing we ran into was the fact that different parts of systems engineering had their own tool, special tool. Everybody was using doors for requirements, and then you have to go get a risk tool, and then you have to get project management tools too, because there's a lot of project management in systems engineering as well, and on and on. And next thing you know, you need 8 to 10 different tools to do the job, and now none of these things work together.
right, no integration.
No integration. So you spend all the time duplicating information between the tools because they're all different databases. So now that configuration management problem is exacerbated, especially now if I add a team to all that, I'm in big trouble. So we recognized that we needed to provide the functionality that we needed across systems engineering and program management. And so we've done that, and we have all that. So we actually have that layer of the life cycle process taken care of pretty well. And then we've worked hard on design engineering integrations with specific tools in the design space. So for software, we use GitHub, and we integrate with that directly. So what you do is you create requirements in Innoslate, and you push them down as issues into GitHub. And then now there is duplication there, but we have a synchronization tool that we created with it that allows us then now to update as those requirements get satisfied. It updates the status in Innoslate. We started with AI back in, oh gosh, at least a decade ago, where we were using natural language processing as that
Okay.
of AI, and which is really the basis for these large language models, by the way. It's the same fundamental technology, it's just they've applied it to a much bigger data set.
Okay.
And they have algorithms that optimize that to be able to be done in real time as opposed to taking forever to do.
Right.
But so we've done that for quite a number of years, and we use that to help us look at quality of requirements, quality of the modeling. We have 68 heuristics we check for that. We also use it to help us look at traceability.
Okay.
For that. So those were the basic NLP tools we built in Innoslate. Now we've been pursuing the generative AI, and particularly we've been using ChatGPT has been probably our main workhorse. We included that as a chatbots in the tool about a year and a half ago, actually. What we've done with that is kind of use that to explore. The other thing we did with it was we trained it to our help center. So it gave us a chat bot for our help center. So we have automation for creating risks from requirements, and that includes the probability consequence, the mitigation possibilities, a lot of information that you gather for this risk and set of risks. Similarly, we've also looked at test cases, how to build test cases off the requirements. These are all things that are really time consuming and difficult for people to do. They might spend a lot of time on that requirement, but then they got to, oh, how do I build the test case for this? And how do I get the risks? And that takes a lot of time. And this simplifies that whole process tremendously. It's only as good as the prompting you're doing too for when you do this stuff. A lot of people are playing with diagram generation. Is there a way to help us build diagrams faster, better, easier?
Mhm.
every time I turn around, there's another idea I hear or see, or somebody else has done something in another tool. So we go, oh, we got to go do that. And you still have the chat bot to do anything you want. I mean, so I could have it help me derive requirements, for example. For the testing side of it, we have our test cases all set up in line of our test sheet, basically in our test center. And then we use Selenium and JUnit to run the automated tests.
Hmm.
And then it then tracks it and updates the status in Innoslate. So we took what was a 3-day manual process, and now it becomes concurrent with the actual running of the test cases. So it's like a 2 or 3 hour total process now.
And what kinds of problems are you using these tools to solve?
Well, we work on any kind of system. So anybody who's trying to do systems engineering activities on projects, we do stuff for the military mostly. We have people commercially doing it for power plants and medical devices and on and on and on. You just think about what can you apply it to? You can apply it to anything.
How would it look to apply it to economic modeling around technology investments, for example?
Since we have cost in our models, we can actually look at cost. And so as you build, and particularly we build a behavioral model, which is where most of the time you can define things well as a process.
Hmm.
And so that becomes a behavioral model because it allows you to interact with it and the human is part of that process, right? And the human functions that are going on are part of that. And so that interaction back and forth, and everything can have a cost associated with it. And then as you run that over time, you will accumulate the costs. And so now then I run that in Monte Carlo, and then I can get a feeling for my risk in terms of both cost and schedule as I do that modeling. I know we did a lot of work for the Army about disaster relief and how to help do that for other countries.
Okay. Can I get you to think out loud for a few minutes about where you think AI is going and what the implications of that are going to be for modeling work?
So I do think it's going to help us generate better models. It's
Hmm.
not just create a model, but how do you create a good one? I mean, and good is very hard to quantify. When you really look at a model, it's really about does it communicate to you what you're trying to get people to understand. Now, we do have a decision element in our tool. It's part of the lifecycle modeling language. I mean, my number one goal is to improve the discipline. How can we do better systems engineering? Because the problem we run into is if we don't do good systems engineering, then we end up making bad products, and sometimes they're very unsafe products. Most people approach systems engineering in a deterministic way. They think they can define everything well enough that
Hmm.
they have a solution. That is completely unrealistic. People have to interact with these, and
Hmm.
are not predictable. Maybe
And
with general bounds, and you can do some general things, and so like macroeconomics works, right? You have that macro way to look at
mhm.
things. When you start getting down to the individual level,
Yeah.
it's not very predictable.
Yeah. Well, and the other aspect of unpredictability is the future. So what we're modeling is how technologies might evolve over the next X number of years.
Yes.
And so you're dealing with uncertainty by definition. There's a real opportunity there to help leaders understand the consequences of policy decisions that maybe they may be making in the present, how that might play out with social issues, cultural issues, economic issues, technical issues over 3 to 5 years or potentially longer, although things are changing so fast that it's hard to imagine looking further in the future than that.
In fact, we just put together another addition to our next release is going to include social network analysis.
Wow. Okay.
You can actually build your social networks, and it will talk about the connections and things like that between those different pieces of it.
Okay.
It certainly has application for policy as well.
Yeah. Well, that's what we're talking about basically is helping leaders formulate policy by giving them better insight about the future than what they have now.
Well, and in actually building the policies so that they're more systematic.
Yeah.
Uh, and if you look at a lot of policies have processes in them.
Right.
And it's fascinating to me that most people don't model those processes.
Interesting. Yeah.
And so they don't know if they're going to work or not. Can I push the envelope on these processes so that I make sure that we really will work in all the circumstances I care about?
Yeah. Yep.
So we do that in systems engineering. We call that a concept of operations. We
Right.
set a set of scenarios, and then if you're doing it well, you model all those scenarios to make sure they actually work together. So actually, in my book, Real MBSE, I actually talk about how to do that and even come up with the right set of scenarios. It's a downloadable ebook, or you can get it off of Amazon.
So here's another use case test I want to do. Another friend, colleague of mine, is using systems modeling in the J. Forrester family of systems models to look at climate and energy transition models. He's a senior executive with Michelin. And so he's trying to model, how the energy transition is going to go, what the climate impacts would be, and for example, how that would impact on Michelin's operations in various parts of the world if there were climate events that forced them to shut factories, blah blah blah. So it's system dynamics is I think the technical domain, basically trying to understand impacts of elements of systems on the behavior of the whole system and interactions between elements of a system. And Forrester pioneered using that in the computers of his time. So do you think Innoslate would be applicable to that type of modeling?
So there is a tool actually that we have that does that to a certain extent. It's called the N-square diagram.
Okay.
It's used to look at connections between things.
Yeah, that's basically what we're talking about.
Yeah.
Is there a demo of Innoslate on the website?
Oh yeah, in fact, you can go sign up for free.
Okay. It was great talking with you. Thanks for fitting me in at the end of the day. I really appreciate it.
Oh, my pleasure. Thanks, Landon.
We'll be in touch soon. Take care.
Bye.
All right. Good night, Steve. In this channel, we've progressed from rather general discussions about the future of AI to very specific technical discussions about AI agents, and in this case, modeling and systems modeling. These are essential techniques for helping us to understand how to optimize the systems that we design, whether those are hardware or human systems, it doesn't matter, to help us understand risk and to model that risk in order to make the best possible decisions. The world is only becoming more complex, and our capacity to model complexity and to understand the possibilities for the future becomes an essential capability for achieving a future that we might prefer.